Dear students, we have already completed practice set 3.3. Now we have to learn some properties regarding circle and angles with the help of some activities here. Let us see here textbook page number 64. Here is a circle. In it, AB is a chord. Let us see here. AB is a chord, and angle ACB is a central angle. Angle ACB is a central angle. Here also take point D. Take point D on the major arc. Here ADB is a major arc and AEB is a minor arc. So take a point D on the major arc. So here let us see, we have to measure angle ADB. You will find here angle, measure of angle ACB means measure of central angle is twice of major angle ADB. Okay. Here also you will find angle AHB, congruent angle ADB, congruent angle AFB, and congruent angle AGB means angle AHB, angle ADB, angle AFB, and angle AGB. All these angles are congruent to each other. Why? Because they are on the same arc. They are on the same major arc or minor arc. In this way, you can find also here angle AEB, congruent angle AIB, angle AEB, congruent angle AIB. Why? Because these two angles are on the same arc, that is AEB, arc AEB. So once again I am telling you the measure of angle ACB, the measure of angle ACB is twice of the measure of angle ADB. And angle ACB is twice of angle ADB. Here you will also find angle ADB plus angle AEB is equal to 180 degree. Means here you can definitely find the sum of these opposite angles, means AEB and angle AEB and angle ADB is equal to 180 degree. Okay. Now let us see here on page number 65. Now we have to learn about inscribed angle. What mean by inscribed angle? Let us see here. Let us see in this figure. C is the center of a circle, and the vertex D, the vertex of angle PDQ or angle ADB, is the vertex is D. So the vertex D of angle PDQ lies on the circle. Let us see here, it is on the circle. The arms of angle PDQ intersect the circle at A and B, point A and B. Such an angle is called an angle inscribed in the circle or in the arc. Such angle is called an angle inscribed in the circle or in the arc. So in this figure, angle ADB is inscribed in the arc ADB. Angle ADB is inscribed in the arc ADB. Okay, so it is called as inscribed angle. Now we have to learn about intercepted arc. Let us see on next page, page number 66. Let us see here. You can see here are 6 figures. In each figure, the arc of a circle that lies in the interior of the angle ABC is an arc intercepted by the angle ABC. The points of intersection of the circle and the angle are endpoints of that intercepted arc. Each side of the angle has to contain an end point of the arc. So here, let us see in the figures first, second and third. Let us see in the figure first, second and third, only one arc is intercepted by that angle. Here you can see in the first figure, here arc AC is the only arc is intercepted by the angle ABC. Then here also in second figure and also in third figure, you can see here only one arc is intercepted by that angle. And in the figure number 4, 5 and 6, in the figure 4, 5 and 6, you can see that here 2 arcs are intercepted by the angle. Let us see here, this one is 1 and this one is second. Here 1 and second, here 1 and second, means here 2 arcs are intercepted by the angle. Also you have to notice that only one side of the angle touches the circle in second and fifth figure. Second and fifth figure, you can see that here only one side of the angle touches the circle, but let us see in the sixth figure, both sides of the angle touch the circle. And let us see in the figure 3.44, here the arc is not intercepted, is not intercepted arc, as arm BC does not contain any endpoint of the arc. So here the arc is not intercepted arc. Okay. So now after the definition of inscribed angle and intercepted arc, now we have to see the important theorem of inscribed angle theorem. Inscribed angle theorem. Let us see the theorem first. The measure of an inscribed angle is half of the measure of the arc intercepted by it. The measure of an inscribed angle is half of the measure of the arc intercepted by it. Here we have three possibilities. Let us see here in the figure. In a circle with center O, here O is the center of the circle, and angle BAC, is inscribed in arc BAC. Okay, arc BDC is intercepted by the angle. Arc BDC is intercepted by the angle. So now here given, first of all we have to write given. With this figure, you can write given. In a circle with center O, angle BAC is inscribed in arc BAC. Then arc BDC is intercepted by the angle BAC. Now we have to write to prove angle BAC is equal to half measure angle BDC. Angle BAC means measure of inscribed angle is equal to half measure of arc BDC. Now here we have to construct something. In construction, draw ray AO. It intersects the circle at E, point E. Then draw radius OC. So now we have to write down the main part of the theorem, that is proof. With the help of this figure, we have to prove it. Let us see in triangle AOC. In triangle, here let us see in triangle AOC, side OA, congruent side OC. Side OA, congruent side OC. Why? Because radii of the same circle. So this is isosceles triangle. So with the theorem of isosceles triangle, we can show that angle OAC congruent angle OCA. So here in third line, angle OAC is equal to angle OCA. Reason is theorem of isosceles triangle. Okay. Now let measure of angle OAC and also measure of angle OCA is equal to x, and there is number 1. Now angle EOC is the exterior angle of a triangle AOC. Angle EOC is an exterior angle of triangle AOC. So here now angle EOC is equal to OAC, angle OAC plus angle OCA. Here reason is exterior angle theorem of a triangle. Exterior angle theorem of a triangle. Means here the theorem of exterior angle of triangle is measure of an exterior angle of a triangle is equal to the sum of the remote angles of the triangle. Okay, so here angle EOC is equal to angle OAC plus angle OCA. Okay, reason is exterior angle theorem of a triangle. Now here OAC plus OCA means x plus x is equal to 2x. So angle here EOC is equal to x plus x 2x, x plus x 2x. But this one is central angle, so measure of arc EC, here EC is equal to 2x degree. Definition of measure of an arc, there is number 2. Now from 1 and 2 we can show that angle OAC is equal to angle EAC is equal to half of measure of arc EC. Yeah. Why? Because x is half of 2x. Similarly here number is 3. Similarly drawing seg OB here, we can prove that angle EAB is equal to half measure of arc BE also. Here number is 4. So now we can add them, means here let us see angle EAC plus angle EAB, angle EAC and angle EAB is equal to half measure of arc EC plus half measure of arc BE. Here reason is from 3 and 4. So angle BAC, why? Angle EAC plus angle BAE is equal to angle BAC. So angle BAC is equal to half measure of arc EC plus measure of arc BE. So angle BAC is equal to half measure of arc BEC. That means half measure of arc BEC means BDC. So number is 5 here. So in this way we have proved 2 possibilities. Means here the center of the circle lies on one of the arms of the angle and in the interior of the angle. Now the third possibility, that is in the exterior of the angle. Out of these first 2 are proved in here number 3 and number 5. Now we have to prove third possibility. Let us see in the figure. Here the center of a circle is in the exterior of the angle. In such a way, here let us see proof. Angle BAC is equal to angle BAE minus angle CAE. angle BAC is equal to angle BAE minus angle CAE. So here angle BAC is equal to half BAE, that means half of measure of arc BCE minus half measure of arc CE, okay, from 3. So here angle BAC is equal to half measure of arc BCE, measure of arc BCE minus measure of arc CE. So here we have to subtract them, means bigger arc minus smaller arc. So angle BAC is equal to half measure of arc BC, number 6. So in this way we have proved inscribed angle theorem. So the measure of an angle subtended by an arc at a point on the circle is half of the measure of the angle subtended by the arc of the center. Okay. Now here corollaries of inscribed angle theorem. First one is angles inscribed in the same arc are congruent. Means here let us see in this figure we can see that angle PQR and angle PSR are in the same arc. So they are congruent to each other. That means angle PQR congruent angle PSR. Okay. Let us see next. Angle inscribed in a semicircle is a right angle. Here you can see that seg AC is the diameter of a center of a circle with center M here. So here arc ABC is a semicircular arc. Also you can see that arc AXC is also a semicircular arc. And angle ABC is inscribed in the arc ABC. So here by the help of inscribed angle theorem we can say that measure of angle ABC is equal to half measure of arc AXC. Okay. So now we have to see cyclic quadrilateral. Let us see cyclic quadrilateral. The theorem of cyclic quadrilateral. First of all, cyclic quadrilateral means what? See here. If all vertices of a quadrilateral lie on the same circle, if all vertices of a quadrilateral lie on the same circle, then it is called a cyclic quadrilateral. What mean by cyclic quadrilateral? If all vertices of a quadrilateral lie on the same circle, then it is called a cyclic quadrilateral. Once again, if all vertices of a quadrilateral lie on the same circle, then it is called a cyclic quadrilateral. Okay, now theorem of cyclic quadrilateral. It is important theorem for us for the coming examination, board examination. So I am solving on a notebook, you can see here. Then here the points to remember, but before that we have to solve here theorem of cyclic quadrilateral. So let us see here. First of all, I have to write here theorem of cyclic quadrilateral. Yeah, theorem of cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are supplementary. Here, opposite angles of a cyclic quadrilateral are supplementary. Supplementary means their sum is equal to 180 degree. Okay, so first of all, here I have to draw a cyclic quadrilateral. Let us see here. Here A, B, C and D is a cyclic quadrilateral. Let us see in the figure. A, B, C, D is a cyclic quadrilateral. Now I have to write given here. Given quadrilateral ABCD is a cyclic quadrilateral. Quadrilateral ABCD is cyclic quadrilateral. Okay, now to prove means opposite angles of a cyclic quadrilateral are supplementary, means their sum is 180 degree. Means first angle B plus angle D, angle B plus angle D is equal to 180 degree, and also second one is angle A plus angle C. Angle A plus angle C is equal to also 180 degree. Okay, now I have to write down proof here. Proof. Let us see arc ABC. Arc ABC, here you can see in the figure, arc ABC is intercepted by the inscribed angle ADC. Arc ABC is intercepted by the inscribed angle ADC. Yeah, so angle ADC is equal to half measure of arc ABC. Similarly, here angle ABC is also inscribed angle. Similarly, so angle ABC is an inscribed angle. It intercepts arc ADC. So angle here ABC is equal to half measure of arc ADC. Number 2. Now we have to add sentence number 1 and 2. So angle ADC plus angle ABC is equal to half measure of arc ABC plus half measure of arc ADC. Now half is common, so angle ADC plus angle ABC is equal to half of measure of arc ABC plus measure of arc ADC. But the sum of the measures of arc ABC and arc ADC is equal to 360 degree, because it constitutes a complete circle. So half multiplied by 360 is equal to 180. So we can see that angle ADC plus angle ABC is equal to 180 degree. Similarly, we can prove that angle A plus angle C is equal to 180 degree. So now I have to write proof here. Arc here ABC, arc ABC is intercepted by the inscribed angle ADC. Inscribed angle ADC. Arc ABC is intercepted by the inscribed angle ADC here. So angle ADC is equal to half measure of arc ABC. Here number is 1. Here reason is inscribed angle theorem. Inscribed angle theorem. Okay. Similarly, also here angle ABC, angle ABC is an inscribed angle it intercepted intercepts arc ADC. It intercepts arc ADC. So here we have to use also inscribed angle theorem. So angle ABC is equal to half measure of arc ADC, and here number is 2. So now we have to add statement number 1 and 2. So angle ADC plus angle ABC is equal to here half measure of arc ABC plus measure of plus half measure of arc here ADC, and here reason is from 1 and 2. From 1 and 2. Okay, so here 1 upon 2 means half is common. In bracket measure of arc ABC plus measure of arc ADC. Okay, so here angle ADC plus angle ABC is equal to half into measure of arc ABC plus measure of arc ADC, that means complete circle. So here 360 degree. Reason is arc ABC and arc ADC constitute a complete circle. Okay, so here 2 ones are 2, 2 ones are 2, remaining is 1, means 16, 2 8s are 16 and 2 zeros are 0. So answer is 180 ones are 180. So here angle ADC plus angle ABC is equal to 180 degree. That means angle B plus angle D is equal to 180 degree. Now here this next part of it. Similarly, we can prove angle A plus angle C is equal to 180 degree. Okay, so this is the important theorem for us. Remember it very well. Now here corollary of cyclic quadrilateral theorem. An exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. An exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. Now here converse of cyclic quadrilateral theorem. Let us see the theorem. If a pair of opposite angles of a quadrilateral is supplementary, the quadrilateral is cyclic. What is the theorem? Once again I am telling you, if a pair of opposite angles of a quadrilateral is supplementary, the quadrilateral is cyclic. Okay, now the important theorem is also means the statement of a theorem is important, not the total theorem. If 2 points on a given line subtend equal angles at 2 distinct points which lie on the same side of the line, then the 4 points are concyclic. Here 2 points on a given line means line is AD and 2 points are B and C here are subtend equal angles at 2 distinct points which lie on the same side of the line, then the 4 points are concyclic. Okay, now here the points to remember. Let us see the main points. First one, the measure of an inscribed angle is half the measure of the arc intercepted by it. Second one is angles inscribed in the same arc are congruent to each other. Then number 3, angle inscribed in a semicircle is a right angle. Then if all vertices of a quadrilateral lie on the same line or same circle, then the quadrilateral is called a cyclic quadrilateral. Number 5, opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Then number 6, an exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. Number 7 is, if a pair of opposite angles of a quadrilateral is supplementary, then the quadrilateral is cyclic. Number 8, if 2 points on a given line subtend equal angles at 2 different points which lie on the same side of the line, then those 4 points are concyclic. Then number 9, let us see the figure. Here the vertex of angle AEC or angle CEB is in the interior of the circle. So angle AEC is equal to half measure of arc AC plus measure of arc BD. Then angle CEB is equal to half of measure of arc AD plus measure of arc CB. And now let us see on next page, number 10. Here the center of a circle is in the interior part of the in the exterior part of this circle. So here angle BED is equal to half measure of arc BD minus measure of arc AC. So here now we are seeing about theorem of cyclic quadrilateral. Let us see, we have already solved here theorem of cyclic quadrilateral. It is very important to us. I hope you better understood it. Okay, so bye students.